Working it a little left to right up the right-hand side.
Names are Kyle, Favre, Aiden, Tumbokon, Brandi, and Brady, Suter, and today we will teach you the physics of a golf drive.
Our goal for this project was to find the physics of a golf swing and help people perfect their swings. A lot of things come into play when hitting a golf ball.
The first thing you need to know is where to place your feet and how to swing the club. Stand so the ball is at the heel of your front foot. You need to have a stance where your feet are even with your shoulders. Bend your knees slightly and transfer most of your weight to your front foot to encourage a downward strike on the golf ball. When you swing, you don't want to use your lower body. Swing all the way through with your hand leading the swing and accelerate upon impact. One tip is to keep the speed of the club consistent throughout the whole swing. One thing you need to know is that distance is proportional to force. So if you put a lot of the force on the ball will go further.
The first concept that we calculated for is the estimated horizontal velocity of the ball in the air. To find velocity, you need to find the distance of your drive. This was 115.824 meters. Next, you need to find the time it took for the ball to go, which was 3 seconds. Then you divide the distance by the time to find the horizontal velocity, which was 38 meters per second. After that, we calculated for vertical velocity. The equation for vertical velocity is the acceleration of gravity, which is 9.8 meters per second squared, times the time it took for the ball to fly upwards in the air, which is 1.5 seconds. So the vertical velocity is 14.7 meters per second. When you're driving a golf ball, horizontal velocity should be similar to vertical velocity. But when you're chipping a golf ball, vertical velocity should be much greater than horizontal velocity because the ball goes at a higher launch angle. To find the total velocity of the ball, we found the hypotenuse of the two other velocities, and we found it was 40.7 meters per second.
The next concept that we calculated for is the launch angle of the ball. Typically, you wanted to have an angle of 45 degrees upward for an average projectile. When we tested it, we concluded that we usually hit the ball with an angle of 23 degrees. The concept that we calculated for is the force of the club hitting the golf ball. The equation for force is mass times velocity equals force times time. The mass of the golf ball is 0.046 kilograms. The velocity is 40.7 meters per second. The time is 0.005 seconds. Once you have found these three variables, you plug them in to find the force, which is 3,744 newtons, or 841.681 pounds.
We also calculated for rotational inertia, which is resistance an object has to torque. The equation for rotational inertia is mass times radius squared. The mass is 46 thousandths of a kilogram, and the radius is 21 thousandths of a meter. So the rotational inertia is 2.094 times 10 to the negative fifth power in kilometers per meter squared.
Thank you.